So we'll see what anomers are. Anomers, the diastereomeric ring forms differing in configuration only at the chiral center produced due to cyclization are called anomers. We know that this is the open chain structure of glucose. This can have two forms, that is the alpha D glucose and the beta D glucose once it is forming a cyclic ring. So in the cyclic ring, anomers means that once the cyclization is taking place, once the cyclization is taking place, those diastereomers which differ only at one chiral carbon atom. If you are comparing two molecules, means we can say that only there is a change or difference in the configuration at only one chiral carbon atom. Then such pairs are known as the anomers. In the case of epimers, we were discussing about the same thing, but it was the open chain structure. For open chain structure, if there is a change in the configuration of at only one chiral carbon atom, it is known as epimers, whereas in the anomers we say that it is a change in the configuration of chiral center, only one chiral center which is formed due to cyclization. Here the chiral center which is formed due to cyclization is this is the first carbon atom. This is getting cyclized, so you're getting two configuration possible, and these are known as the anomers. The alpha D glucose and beta D glucose differ only at the first carbon atom which is formed, or this particular configuration is formed due to the cyclization. So such pairs are known as the anomers. Another next important features shown by carbohydrates are known as mutarotation. We can say that aqueous mutarotation, and this is a property that is shown by carbohydrates. We can say that if you have a solution, aqueous solution of D-glucose which is in the open form, we can say that the anomeric forms will be formed, or you can say that this D-glucose, or we have this alpha D glucose will be reversibly converting to the open structure of D glucose, and which further will be converted to the beta D glucose. Suppose you are taking alpha D glucose, the aqueous solution of the alpha D glucose, meaning you are taking alpha D glucose and then adding water to it. We can say that after some time the alpha D glucose will be converted to the open chain structure, that is the D glucose, and further it will be converted to the beta D glucose. And how this conversion is possible? We can say that there will be a specific rotation. Specific rotation of plus 112.2 degree. That is all glucose are found to be, the glucose that are found in nature are found to be in the dextro-rotatory form, and since it is dextro-rotatory, it has got a specific rotation of plus 112.2 degree, whereas for glucose open chain structure will be having plus 52.7 degree, and we can say that beta D glucose has got again the specific rotation of plus 18.7 degree. So once you are taking the aqueous solution of alpha D glucose, this alpha D glucose which has got 112 plus 112.2 degree specific rotation. This is alpha D glucose. Alpha D glucose with a specific rotation of plus 112 degree. What happens is that slowly the specific rotation of this alpha D glucose will be reducing, and it falls to 52.7 degree centigrade. 52.7 degree, and therefore there will be an equilibrium attained. And further, if this freshly prepared glucose with the shows a specific rotation of plus, and which gradually falls to 52.7 and then remains steady over here. Once it is forming 52.7 means it becomes steady. And suppose you have crystals of beta D glucose. Okay, suppose you have beta D glucose, and this beta D glucose, if it is dissolved in water, again the specific gravity, the specific rotation of beta D glucose will be increasing, and that will be increasing to plus 52.7 degree. And once it is forming 52.7 degree means it becomes steady. Okay, that value becomes steady. And this process, okay, the change in the specific rotation of a sugar solution, okay, we can say change in specific rotation of a sugar solution with time until a constant equilibrium value is reached, it is known as mutarotation. Okay, we can say, suppose you are taking alpha D glucose, which has got a specific rotation of plus 112.2 degree. It will be the solution of it. If you are dissolving in water, it will be the specific rotation. Once you are measuring, it will be reducing to plus 52.7 degree, and then it becomes steady. And that is because the alpha D glucose, once in the solution form, will be converted to the open chain structure. And if you are taking the beta D glucose crystals and then dissolving in water, we know that beta D glucose will be having a specific rotation of 18.7 degree, and the specific rotation of this will be increasing to about 52.7 degree, and then it becomes stable, meaning the beta D glucose will be unstable in the solution form and will be converted to the open chain structure. And the change, the process in which there is a change in the specific rotation of a sugar solution, okay, once with time is known as muta rotation. Okay, the peculiarity in this is that the alpha D glucose, then the D glucose and beta D glucose, all has got the plus sign, meaning all are dextro rotatory. Okay, so this is what the muta rotation is very important. Muta rotation, epimers, anomers are all very important, that will be always asked.